presentation of khtml map library. So first, before I begin, I'll make a live presentation. And if you have a laptop, you just can enter this address, and you can see the same as at the beamer. And there are also some things to test. You can do it with your own computer. Okay. khtml.maplib, it's a library for web browsers. It works on desktop browsers and mobile browsers. So it works on iPhone and Android. It works best on the Chrome browser, on all WebKit browsers. It has multi-touch support on iPhone. It's very fast. Should be much faster than OpenLayers. It has a lag-free user interface. So if you give a command to the map, it will react immediately. It's very small. It's only at the moment it's 80 kilobytes. If you zip it, you have only transferred 20 kilobytes over the network. So it's like 2 tiles. Status, it's still better. So you will find lots of bugs. But there's some parts in the library that's already usable. Other parts are still heavy. There's still heavy development. So the development team, this year I got support from Switzerland, Mr. Hengart and Mr. Kemper from Hochschule Rapperswil helped me a lot. They was working on vector graphics, vector overlays. They also did some KML, but I will not present it today. So at the moment, Ewald Wieser from St. Pölten is working on markers. He's doing a Google Summer of Code project. So we will see next month lots of progress on markers. So my name is Bernhard Zwischenbrugger. I work at the University of Applied Science in St. Pölten and also at Prisma Solutions in Mödling. And there I'm working with OpenLayers, which is a great product also. So I want to present today the base map without overlays, then overlays with markers, vector layers, bitmap overlays. Then I show you the speed of the map with some benchmarkings. Then we start coding a little bit. And then I show you some parsers. For example, KML, OSM. To load these things into the map, you need a parser. Okay, let's start with the map. So, before we start with the map, a little bit more theory. There's one data type very heavily used in this map. It's called lat_long. It represents a geopoint. It has a longitude, latitude, as we use in OpenStreetMap. There's only one coordinate system supported at the moment, so only the VGS84 in the GPS device and so on. So this data type is not visible. One point can be shared among markers and vectors. So point can have exactly the same point as the vector can have the same point as the marker. So exactly the same. So, and then there's a callback function on this data type. I will show that later. Maybe you have keep in your back head. So now, here's the map. To initialize the map, we need 3 lines of code, 3 lines of JavaScript code. It's very similar to Google Maps. And now I want to show you how the map is working. So the most important thing for this map is the mouse wheel or the emulation on the touchpad. I can do everything just with zooming in and out. So I zoom out, I go to another place. For example, I go to Washington, zoom in there. It takes maybe 10 seconds, and I'm on every place I want, on the Earth. For example, this is the Pentagon. But I have to know where this place is, of course. But if I use this map, I will know where the places are. So another example, I zoom out again. Now I zoom into the Grand Palace in Bangkok. So here's Bangkok. I put the mouse exactly to Bangkok. I will zoom in there. Okay, here I can see the river. So there's the river, going up here, and over here's the Grand Palace. I put the mouse there, zoom in, and there's the Grand Palace. So we have a new dimension. We don't have X, Y, we also can zoom in. We have the Z coordinate. So, zoom out again. Okay, again, 3 lines of code, and it's done. And of course, you have to embed the JavaScript library, 4 lines of code. You can also embed the map to normal HTML. For example, here's some float design. Small maps are very fast because you don't have to load that much tiles. Also, these maps are active. Next page. So, if you have a mobile phone, iPhone or Android, you can make a screenshot. Just take the QR reader. I do it here. So, then map is starting, and Chairman said this. Okay. So, zoom a little. Not so perfect focus. So then I can put the map to the home screen, and then it's full screen. I do that. Home screen. Okay. So and now I have a full screen browser map. So you don't see the difference to a normal application from App Store. That's normal. HTML is browser. I can do multi-touch. There's also GPS and things like this. Here, position. I should go to Vienna, and here we are. So it's also possible to use the JavaScript library to make normal apps. Maybe you know PhoneGap. There's some libraries you can compile it, and then you have real applications. Okay, next. So the normal map without overlays should work perfect. I didn't test much on Windows, on Internet Explorer, but it should work. So if not, please tell me. So next things are not that stable, but they are getting more stable with time. So overlays. That means we can put markers, vector layers, and things like that to the map. And we start with some vocabularies. Sorry. So, okay, take it back. Okay, overlays. So, some vocabularies. All the overlays are called features. In OpenStreetMap, we have nodes or points of interest, and we call it marker or point. And we have way, and in the library it's called line string or polygon if it's an area. Relation, for relations, probably we use multi-line string, multi-polygon, and so on. And a container for all these features is the feature collection. So maybe you already know these vocabularies. They are from GeoJSON, which is a very, very easy standard. So, and GeoJSON is the internal data structure of this library. So if you know GeoJSON, it's very, very easy to do programming with this. Okay. Okay, here's the marker. There will be lots of changes, as I told before. Ewald Wieser is doing work on this, and we will see changes on that. We will see markers with nice pop-up window and things like that. At the moment, there are only very, very simple markers available. Just, sorry, I wanted to do the laser. So this is normal JavaScript. I'm creating an image object. Then, as I said before, I create this point, this lat long object, and then the fourth line, so maybe I can mark it here, maybe a little bit bigger. Oh no, it doesn't work. Okay. So here, I create the marker, and then I append it to the map. The map always has this feature collection. It's a collection where you can put all these features. Actually, it's just an array, but it gets visible on the map. And then I use the method append child, and I can put the marker to the map. So append child, if you know JavaScript, that's a standard DOM core function. So I use the same syntax. Okay, that's the markers. So I will not talk very much about markers because they will change a lot. Next, vector graphics. Here I have two vectors. No, obviously the wrong one. The first is called line string. Next one, a polygon. So this syntax here is also GeoJSON, which is a really, really easy standard. I generate a feature with this geometry. Then I append it to the map. It's the same syntax as with the markers. I use the feature collection and append markers and vectors with the same syntax. If you know open layers, they have the vector layers and the marker layers. Here it's unified. You use the same layer for markers and vectors. Then, next thing is styling. A vector needs a style. This, for example, here, it's red, has stroke width 7 pixels. And we do it with the same syntax as in SVG. So nothing new to learn if you already know SVG, and nothing to document for me. Then there's another syntax for styling. I do it with class names. If you know HTML, you already know classes. So I just make a class name, and in this class defines that this polygon has these colors and this border. Okay, vector graphics. Then next thing, bitmap overlays. So here I have the syntax. Maybe it's a little bit small to read, but I have an example to show what it looks like. If it's working. Yeah. So here I was collecting many bitmap things. It's not everything legal here. So I use some things that are, some tiles that are not allowed to embed. For example, Google tiles I must not embed, but I did it here. So now I switch to Google tiles. Google has a very fast tile server, so zooming goes even faster. I zoom into Vienna. So I have lots of different tiles. OSMA. Then, very interesting, the no name no-name tiles together with the language overlays. So here, for example, I have German, and I can switch to English. I think these tiles are from Wikipedia, as I remember. Also, hillshade, very nice. I can add more than one overlay, bitmap overlay. So here I have the hike map. Then, as maybe you heard about OpenStreetMap yesterday, I go to the coast. Somewhere, maybe around Rotterdam, we will see nice open sea map things. Yeah. There's some lighthouses, things like that. All these bitmap overlays. So this about the same as in open layers. Nothing special. So, a very nice map I found is it's a very old map. I have found a map of England. Here, old map. And it's a scan of a 100 years old map, but it's very, very slow. It doesn't really load. No, I think that's too slow at the moment. Or maybe here on this side. No. So I can combine this old map with OpenStreetMap names and hillshade and the hiking map and all together. So that's about the bitmap overlays. I go back to my presentation. Okay, so as I said at the beginning, this map is very fast. So I have to prove that. So if something is fast, we have to measure it, and we need some benchmarking. If it's fast, it should also work with lots of data on it. It should be supported by many browsers, and I also have, I will show something about styling here in this chapter. Okay. This is the map, zooming with 1 frame per second at the moment. That's not very fast, but I can show you some things. It's zooming, the font gets bigger and bigger, and then it's switching to the next tile, to the next zoom level, and this goes without gap, so the screen doesn't get white in between these 2 frames. Okay, I request 1 frame per second at the moment, and the map has to render 4 frames at the moment. There's always 1 visible frame, 1 invisible frame. So if the invisible frame is loaded, it's switching, and you don't have this white flashing thing. You have a continuous view. So, you always need 2 frames, but there are 4 frames. If a browser is very slow or the hardware is slow, I don't show all the frames. Some frames I don't show. So if it goes too fast, then just go from this frame, then drop the next frame, take the next frame. But the last frame must be shown all the time. So if I zoom to a specific zoom level, I want really to be at this zoom level at the end. So I have to do the last frame again. So I do it twice, and the result is always the wrong key. The result is at the moment 4 frames. So I go up with the frame rate up to 10. So now we have about 36 frames. Now I go up to 50 frames. No, what's that? So 50 frames. It's zooming very slow, but should be. It's very slow at the moment. Okay. At the moment, this browser and this hardware is able to do 20 frames per second. That's the maximum at the moment, available at the moment. Maybe it's the wrong. Okay. So if we zoomed a little bit, it's a bit slower. So at the moment, it's about 90 frames per second. That's enough for have a smooth zoom. Maybe it's too much. The result, you can hear maybe the fan. So if you have the frame rate too high, it's the computer gets hot. That's all. So more than 50 frames is useless for normal. So now I go up to 500 frames. This computer is not able to do 500 frames per second. Maximum at the moment is 122 frames. About, it drops down to 90. It depends a little bit. So if I give if I request too much frames, there are lots of frames dropped, and this depends on the hardware, on the browser, and also on the map size. So if I make it smaller, if I make my map smaller, frame rate goes up. So now, where am I? Okay. So this is very important on this map to have everything very fast, so I have to measure it. Also, if I do some features to the map, it should be fast. I can add some lines, some line strings. Now I have 5 line strings on the map, and when I'm zooming, they're visible. They zoom with the map. And I go up to 20. I have 20 lines with 20 points, so about 400 points. And now I see if I'm zooming, they're not visible all the time. If I zoom in, then there's only one line visible, and it's visible while zooming. So then I go up to 1,000. That's a lot. So it's not visible while zooming, and you see there are many steps when it builds the new view. Very important, while rendering these ways, I'm able to do some actions on the browser. So it starts to render, but I'm still able to move the map, move and zoom the map. So even if I go up to 5,000 lines, oops, go. 3,500, so 5,000. I have 5,000 lines. It takes a long time to render 5,000 lines on this map, on this hardware. But all the time it's possible to move the map, so it's a lag-free user interface. It's not completely lag-free. It needs about 100 or maybe 150 milliseconds until the map responds. I can measure all this time. To do these 5,000 lines, it takes a long time. It doesn't stop. Okay, so this is done with SVG in the backend. I have 3 backends. One is SVG, next one is Canvas, and for old Internet Explorer, I have the VML. So this is a Linux machine, so I don't have Internet Explorer here. But I can switch to Canvas. So switching from one backend to the next backend is a little bit buggy here. I do a reload. So go to Canvas. Stop. Oh. Canvas. Hop. I hope it's canvas. Yeah, and that's canvas looks same. Also styling is done with the same syntax. I used the SVG styling syntax, the CSS styling syntax, and calculate from the CSS styling syntax to the canvas styling syntax. So I can switch the backhand with the same syntax. So it's only my problem, not your problem if you use this map. So I can add more lines. There's a box should be red. But if I move it, it's red. So, yeah, 1,000 lines on the map is no problem. If you go up to 5,000, you need really good hardware. If you go up to 10 or 20,000, it's not really realistic. Yeah, this page is very important for me as a developer. If I do changes, I always measure these times and keep it fast. So, next page. Okay, here we have a problem. I switched to the offline version. So it's the same, but I have some cached tiles. I have also, so before you have seen frame-based animations. Now I have time-based animations. If I press this button, it will zoom in to Vienna, to this place here, and it takes 2 seconds to zoom in. I zoom out, also 2 seconds. If it's too slow for me, I can change this time. I say 500 milliseconds, it's okay. It's very fast now. And many frames in between I've dropped. I can go also much faster, then it's no animation anymore. 500, it's a very nice zoom. Zoom out, zoom to the next place, zoom in, zoom out, go to the next place. Mödling, that's the place where I'm working. Zoom out. St. Pölten, where my university is. Okay. So it's very easy done. There's only one command you have to use. It's called animated go-to. You give the latitude, longitude, zoom level, and the time, how long it should take to go to this place, and it zooms and moves. Okay, next thing about speed. Here I have a single HTML page with 30 maps on it. I do a reload, and it took about 1 second, maybe less than 1 second, to render all these maps. And they are all active, of course. You can move this map, this, zoom in, move. You can bring it to the foreground, and so on. So it's also possible to put 100 maps on the same map, on the same page, no problem. And also scrolling the page, same speed as before. Okay, let's go on. So, next thing will be coding. If you know a little bit JavaScript, that's interesting for you maybe. If you don't know, maybe it's not so interesting. I tried to make a very easy to use application programming interface. I was thinking about some use cases. It should be possible to make an editor like Potlatch based on this library. I need layer management. Everything should be object-oriented, and we need event handling, nice event handling. So the result of my thoughts is I use very few commands only, very few objects, very few methods. Then the internal data structure is GeoJSON. So if you know GeoJSON, which is a really simple format, it's very easy to do coding on this. Styling, I've already shown. Styling is very easy. Just as in HTML, you have the style object and classes for styling. And the DOM core object is also used. And there's also object-oriented event handling. That's something that HTML doesn't provide per default. So, okay. So vector styling. Here's a very simple example. I have a pull down here, a select box. Just can change the style, and it's done by this code. Actually, only by this, only half a line of code, and I can change the style, the class name, and it will change already. And I can do, for example, oops, that was an O, not a 0. So border width and opacity and things like that. So styling is very easy. Field style can change the color. Okay, next thing, interaction. I want to know the position of the map, the zoom level. I want to know the position of the mouse. And if I have a marker, I know the position of the marker. That's all done with some 2-3 lines of code. And as I said in the beginning, we have a callback function. It's a lat.long object. It's here. I can do the method add callback function, give the function name, and then here I have this object and can read the latitude and longitude. So if you are interested in things like that, just see the source code here. Next thing, I said a lat.long object can be shared. So here I have 3 markers on a polyline, on a line string. If I move the marker, also the polyline is moved. I only have to give a render command to the line string, and this I do with the callback function of the marker. So 6 lines of code, and the line is editable. And I have to make the marker, of course, yeah. So here, maybe you cannot read that. So here's a comparison. Here's the GeoJSON format, and here's the internal data structure of my library. I just replace all these coordinates with the lat.long objects. Then I add some styling and give this render function. This is very important. If I have to re-render, just call this render. It will re-render and the view is refreshed. So here are some examples of coding. So I always have the map, then all features are together in a feature collection. I have an array, features, 0, features 1, and I can style it. And if I press enter here, it's already styling. So it gets blue. If I write red, it gets red. I just do just give this to the JavaScript and execute it. That's it. I can also have these objects in separate variables here. This is changing. Also the coordinates. If I give a new longitude, latitude. So very easy for programming. Next thing, this is, here I will add, here we'll bring up a new polyline to the map. I only need this geometry. Here are the coordinates, 3 points. And here in this case, I press enter and it's on the map. If I change the coordinates, I have the next one. Go to the end. Join next thing. Also styling, I make it red, and then append it to the map. 5 minutes. Okay, here's some examples of coding. All these features are together in feature collections. Feature collections can also have features, and here I have many things ordered in feature collections. So now everything is shaking. Here is a feature collection with only 2 features, a single feature, there's a polygon, a line string, point. Here are 4 features. So I can make it visible, switch it away. So it's organized in layers, and you can make a tree of layers. Here I can do styling. I have many objects on the display. I can do styling separate on everything. 0.5. Just some examples what I can do with this library. And also the bounding box is always available. It's important if you want to zoom in somewhere. Press here, and these are now in the view. So what else do I have? That's not so interesting. Event handling, yeah, that's interesting. So here I have a rollover event. On this side, you see the result of the rollover. If I do it on this side, you see the result on this side. Then, if I click on it, I can edit. Oops, yeah. And here, if I press down, I make a click, it goes away. So event handling goes in both directions. So object-oriented event handling. Okay, Parsers. There's some interesting things for OpenStreetMap. I can load from the normal OSM API. So that's the map API, so I'm loading ways. At the moment, without style, I just make it black. Next thing, I zoom in a little bit. So here I'm parsing OpenStreetMap XML and do styling. And this time I do it with map CSS. So we have some restaurants. The houses should be in a different color. I don't know what's happening at the moment. Again. Yeah, so we see some point of interest. Also the rows should be different color. Doesn't work at the moment. Okay, I can also save all these things that are in the browser at the moment. There's a function, and then it's serialized to this GeoJSON format. And also I can do it the other way around. Here I load it again from the GeoJSON format. So here the source code is interesting. And at the ending, I have only 1 minute left. So here are some resources. So this presentation is on the HTML SotM URL. Then there's a mailing list, khtml.maplib at freelist.org. Very important. The repository at GitHub, it's not up to date at the moment. I was a little bit busy preparing this presentation. So it will come next weeks, at least when Ewald is finished. And there's the work of Ewald Wieser. Okay, that's it. Are there some questions?
Okay, there are questions. Just for your information, there is the coffee break after this talk, and we're going to take the group picture outside, so keep that in mind when you rush out to the coffee break. And as there is the coffee break afterwards, I think we can give Bernhard a little more time to answer some questions, so just stay how long you ever want.
How will one go on and adding charts to those maps? For example, bar plots or some other kind of plots. So you have a map, and then you have some points, and you'd like to assign a bar chart, bar plot, or some other statistic diagrams to that.
So if you have things like that, they are normal markers. You do normal HTML, makes your marker and put it on the map. So it's normal HTML, you can put it. There's nothing special needed beside that.
And if I want to use a ready charting library of JavaScript, can I draw that on the map, or how would I use that? Because
if it's HTML or SVG, you can just put it on the map. Shouldn't be any problem.
Thank you.
There was also a question somewhere back there, yeah?
Hello. Is there support for pop-ups and such things in khtml, just as in open layers?
Yeah, we will see that in about 1 month. Ewald Wieser is working on this. He's doing this Google Summer of Code project. So here on this address, you will see that things. So then you can click on a marker and see this pop up. At the moment, you don't have.
Hello. Did you use any kind of JavaScript framework behind that, or is it just your plain JavaScript, or did you use jQuery or Closure Tools or something?
No, there's nothing.
And then some compiler to
No,
make it?
I had some code from internet, from some mailing lists, but only short code, but no libraries.
And if I use the canvas element, so you do the hit testing manually on the map? I mean, like on SVG, you still have the information if you click somewhere to get to the marker. You know what I mean?
How much memory it uses?
No, like if I use canvas and I can click on the map, so you can still recognize the clicks on the maps, right? Or you, oh. That's okay.
So maybe ask me later.
With the work on markers that is being planned, do you plan on doing anything with clustering or the problems that occur if you have several markers that are close together, and how to differentiate between the two? Do you provide bubbles or clusters?
There's nothing special about markers. They're just put there where you put it. If there are 2 markers at the same place, they are in the same place.
And so there's no work being done on
So there's no work done on that.
Okay.
But maybe if you write a nice mail to Ewald, he will do it. He gets $5,000, so he has to do it.
No more questions?
So I make a picture.
If there are no more questions, I'd like to thank Bernhard for his nice presentation and view of the khtml.maplib.